Hello everyone, welcome to Mastermind. So this is the part 2. This is part 2 of atmospheric circulation and weather systems, which we were discussing from NCERT. Now in the previous part we have discussed about the air pressure and basics about the air, and I hope you remember the mantra which we discussed. That is, air always moves from high pressure area to low pressure area. We have seen that the high pressure is associated with the cold air and low pressure is associated with the heated air, and the heated air is because of the kinetic energy. The molecules are further spread, and the cold air is closer to the surface because of the gravity. So all these are some of the important points which we have discussed. You can watch the previous part for that. In this we will discuss the pressure with respect to the vertical variation. Before we start the pressure with respect to vertical variation, we have to look at the structure of atmosphere in brief. Structure of atmosphere very briefly. Okay, so this is another chapter actually, but I'll just give you a glimpse of it. Now let us consider this to be the surface. This to be the surface, and temperature over here are mentioned in degrees Celsius, and here we'll see the altitude. Altitude is the height. Altitude. Okay, so altitude. Now the first layer which comes is called as a troposphere. Troposphere. This is the structure of atmosphere. If you are taking one side of the atmosphere, then you have troposphere. Later you have stratosphere. Next you have stratosphere. Above stratosphere you have mesosphere. And later on you have thermosphere. And very much on the top you have exosphere. These you have to remember. So troposphere, stratosphere, mesosphere, thermosphere. Now the density is highest near the surface. We have seen that. Here we have seen that highest near the surface. So if the air is present over here, then its density is very high near the surface. It is highest near the surface of the earth. And as you go up, the density of the air decreases. Okay, density. What is it? Density of the air is more at the surface. So as you go up, the density decreases with height. First point. We still are not going to discuss about the actual topic, which is the vertical variation. We are discussing about the basics of the structure of atmosphere. So the density is highest near the surface of the earth. That is, density decreases with the altitude. So we have seen what are the components, which is troposphere, stratosphere, mesosphere, and thermosphere. Troposphere, stratosphere, mesosphere, thermosphere, and at last there is exosphere. Now when it comes to vertical variation of pressure, this is the portion which we have taken for the atmosphere already. The structure we have seen, whatever are the basics. Here there is again tropopause, then there is stratopause, etc., which are present. What are the weather phenomena which are happening? Why does the aeroplane fly on the stratosphere, etc.? That is part of the structure of atmosphere. But for basics, we have just taken the structure of atmosphere, and we have seen how it varies, how the density varies. And because the density is also varying, if you are looking at lower atmosphere, what is lower atmosphere? It is closer to this surface. Lower atmosphere, the pressure in the lower atmosphere, the pressure decreases rapidly with the height. Okay, pressure decreases rapidly with height. Correct? Rapidly with height. So if you are going on top over here, if this you consider as a lower atmosphere, which is troposphere, then as you go up, the pressure decreases, which we have seen already. Okay, we have seen already in the part 2 that as the air heats up, it goes up and it spreads further. Okay, and as it goes up, the pressure also comes down, because if the pressure is more, it will be on the surface of the earth. Okay, so the pressure decreases rapidly with height. Now how much it decreases? The decrease is about 1 MB for each 10 meters. Okay, if you are looking till here, let us say this is at 20 kilometers, just an example. So for every 10 meter there is 1 millibar. Okay, there is 1 millibar reduction in pressure. 1 millibar reduction in pressure. In the previous part we have seen that the atmospheric pressure is measured in the unit of millibar. So for every 10 meter, there is a decrease of 1 millibar of the atmospheric pressure. But throughout it is not the same. It is not the same rate for decreasing. It is not decreasing in the same rate. It doesn't mean that till you go on top, for every 10 meters 1 millibar only will decrease. It differs depending upon the pressure and temperature at selected levels. So it differs. So if you look at sea level, the sea level which you have seen is 1013.25, and this is taken at temperature of 15.2 degrees centigrade. Okay, so this is the base which you have taken. Now if you are considering to move above in sea level, so if you go till 1 kilometer, it will become 898.76. These are the information which is given in NCERT. So this is in MB which you have seen, and this is in degree centigrade. And so here the temperature is 8.7. See, there is decrease in temperature also. If you go up to 5 kilometer, then it becomes 540.48. Then the temperature is minus 17.3. Again there is a decrease in temperature. There is decrease in pressure also. There is decrease in temperature. Then if you go at 10 kilometers, then again it will reduce to 65.00, because every 10 meter 1 MB is reducing. So if you look at here, the temperature is minus 49.7 degrees centigrade. Okay, this shows how the pressure varies vertically. Now the pressure also varies vertically, which you have seen. Along with this, the pressure also varies horizontally. The pressure also varies horizontally, but the vertical pressure gradient force is much larger than the horizontal pressure gradient. Now what is this gradient? It is the change, the amount of change. So vertical pressure is more compared to horizontal pressure. Because one of the reason for that is there is rapid change in temperature also. I hope till here it is very clear. Till here we have discussed about the basics of the air, atmospheric pressure, and we have discussed about the basics of the structure of atmosphere and also vertical variation in pressure. I am taking it very slow because it might get a little complex if you are starting new to the geography, but these are very important part of examination. Most of the times at least one MCQ will come from the atmospheric circulation and weather system, and if you have understood the high pressure region to low pressure region and how it changes according to the altitude, a lot of concept related questions can be very easy for you to answer. But this change from sea level to the top will be very helpful for you when you are writing concept related questions also in prelims, and also the answers in case of mains. In the next part, we'll discuss about this horizontal distribution of pressure. Later on, we'll look at the map. How is it horizontally distributed in across the world map also. But for now, you have to remember that as you go up, the pressure becomes less, and the reason for that we have seen, because it becomes more dense and also there is less temperature, it has already heated, and then there is circulation which occurs. The phenomenon of cyclones, etc. we'll discuss later on, how it changes with altitude and how it changes in northern hemisphere, southern hemisphere, etc. we'll be discussing. For now, you have to remember vertical variation of pressure. The one takeaway which you have to remember is that as you go up, the pressure decreases rapidly with height for some distance at least. Later Later on what happens is, when you go further up, that time the decrease is not that rapid, the decrease is medium. So I hope you have understood about this particular chapter. In the next chapter we'll discuss about the horizontal distribution of pressure. Thank you. I'll see you soon in the next one.